The objective of the lab is to determine the percentage by mass of sodium carbonate in a mixture. The experimental setup includes the following: a crucible, a ring stand, a pipe clay triangle, Bunsen burner, and a mixture of sodium bicarbonate and sodium carbonate. When a measured mass of the mixture is heated in a crucible, the sodium bicarbonate will decompose into sodium carbonate, water, and carbon dioxide, as shown in the equation. The sodium carbonate in the mixture is thermally stable, and hence its mass will remain constant. You will decompose the sodium bicarbonate by heating the mixture in a crucible. This will decompose the sodium bicarbonate into sodium carbonate, which is already present in the mixture, water, and carbon dioxide. The law of conservation of mass says that the mass is always conserved in any chemical reaction. This means that the total mass of the reactants must equal the total mass of the products. And this will certainly be true here, except that the reaction will appear to have lost some mass. This is because the carbon dioxide and water produced will escape the reaction vessel as gases. We will use this loss of mass to determine the percentage of sodium carbonate in the mixture. So the strategy in the lab is to obtain the mass of the empty crucible and the mass of the mixture. Then the mixture will be heated in a crucible, driving off water and carbon dioxide and leaving behind sodium carbonate. Then we'll remass the empty crucible and the sodium carbonate to obtain the mass of the sodium carbonate that remains. So here's an example of some data you may obtain in the lab. Consider the data table to the right. Calculate the percentage by mass of sodium carbonate in the mixture. The first thing we can do here is obtain the mass of the mixture. And here we obtain a mass of 5.36 grams. The mass of the CO2 and water emitted may be obtained by taking the mass of the crucible and sodium carbonate and subtracting that from the mass of the mixture. And here we obtain a mass of 0.95 grams. And then we do a little algebra. And we see, stoichiometrically speaking, the number of moles of CO2 and H2O are equal to each other, and the mass of the H2O and CO2 may be calculated by taking the number of moles produced and multiplying by their molar masses. And so the algebra gives us a number of moles of 0.015 moles of CO2 and H2O. Using that, and using the stoichiometry of the reaction, we see that this corresponds to a mass of 2.5 grams of sodium bicarbonate that was decomposed. We can then use this to obtain the mass of sodium carbonate, and therefore the percentage by mass of sodium carbonate in the mixture.